we will be looking at graphing inequalities. So here we have two examples. The first example, I would recommend graphing this using the slope and intercept method because the slope is readily given here, your x coefficient, because my y variable is already isolated, and here you would have your x-intercept here. So it would start at 2 on the y-axis, and then your vertical displacement would be -5, so down 5, and then a horizontal displacement of 3. So my function, my inequality would look something like this. So you basically graph just like you would a regular function. Now, um, we know it's going to be a straight line, but you need to decide now if it's going to be dotted or if it's going to be solid. How do you do that is here, symbols that are strictly smaller and strictly greater will generate a dotted line. However, here we have the or equal, like the underline, that will generate a solid line because that means that any points that are found on the line are not solution. Only points that are found in the feasible region, which we'll look at right now. So now that we've graphed the line, we need to figure out which side of the inequality is solution. To do that, you do a test point. And I always recommend using 1, 1. It's because 1, 1 is easy to calculate, or even 0, 0. If the equation here, we could use 0, 0, but we could use 1, 1 or 0, 0. Let's use 0, 0. That's a good one, just as long as it's not found on the line. So this will be our test point. So if this point is true when we substitute in the equation, that means that this is part of the feasible region. So let's do that. So is it true that 0 is smaller than 0 plus 2? Yes. So that means that this is in fact my feasible region. Now, if you would have took a point in this side of the inequality, you would found that it would not have been true. Let's do the second one using the intercept method. Now, why do we use the intercepts method? Because this is not in the y mx plus b form, and y would be not easily isolated. So let's do that. What is the y value when x is 0? So let's do that. If x is 0, -4 times what number gives me 8? Well, it's -2. So 2, negative. I have my first intercept. When x is 0, y would be -2. So let's write that down right here. That's the y-axis. And then now let's look at the x-intercept. What is the x value when y is 0? So if I do that in my function, I get 3 times what number equals 8. So if you can't do that in your head, it's 8 over 3 if you wish. Or 3 goes into 8 twice, and then there's 2/3 left. So 2 and 6 repeated. Or you could just say 2 and then 2/3 of the way. So this would be your equation. And here, would this generate a solid or a dotted line? Solid line, because I have the or equal here. So here's my line. Now that I've graphed my equation, I need to find the feasible region. And how do you do that is you check with a test point. So you could take any point minus the ones that will be found on the line, because any point that you pick that are on the line will be solution. So let's pick, last time we picked 0, 0. Let's pick 1, 1 here. 1, 1's a good one. It'll be quite easily. So 3 minus 4. Is that smaller or equal to 8? Of course it is, because this is -1. That means that this is my feasible region. That means any points found in this part of the Cartesian plan will be solution to this inequality.